So, in the previous lecture we talked about centrifugal force. If you use a rotating frame of reference which rotates about some axis, then from that frame of reference, if you are analyzing motion of particles, you must apply a centrifugal force, which is mass of the particle times angular velocity of the rotating frame squared, and then the distance from the axis, multiply all those things. This much centrifugal force in radially outward direction is needed. So, we have done some experiments and all that. Now, once again look at this rotating frame, and suppose someone is using this rotating frame and analyzing this piece of chalk that is placed here on the table. So, as seen from this rotating frame of reference, the piece of chalk is also going in circle, and that circle will be in the opposite sense in which this disc is rotating. If the disc is going this way in the lab, then in the disc frame everything that is at rest in the lab is going in the opposite way in circular paths. So, let us understand, using all pseudo forces that we know, how this Newton's law is applicable or not applicable, or what kind of extra forces I have to put if I want to use Newton's law to analyze this piece of chalk which is kept at rest on the table from this rotating frame. So, if I draw the diagram, let us say this is that disc, and here is the axis of rotation of this disc, and it is going with some angular velocity omega. So, this disc, this whole disc is rotating in the lap frame. So, if it is going in anti-clockwise sense, this angular velocity vector is coming towards us perpendicular to this plane. So, this is the angular velocity vector. You can take this as x axis, then this as y axis, z axis is away from this plane. So, omega vector is omega in k cap direction, and this is the axis of rotation. And from this frame, now I am using this frame. So, this omega I will just erase. In my frame these things are fixed and other things are moving in opposite sense. So, if I remove this arrow from here and this omega from here, but we do remember that this disc is rotating in the lap frame with this angular velocity omega, and from this frame I am looking at some object, say here. At certain instant this object is here, it is at rest in the lab. So, in this frame it is going in a circle, and in the lab this was going anti-clockwise. So, as seen from here, this will go in this direction, in this circle. So, what are the forces, real forces? The real forces will add to 0. In the lap frame, which I take as inertial, it was at rest, no acceleration. So, all the real forces added together will give 0. And then we have to apply pseudo forces. Since it is a rotating frame, I must apply a centrifugal force, and the centrifugal force should be away from the axis. So, when this particle is here, the force should be in this direction, and that is m times omega square times the distance from this axis, this much force outward. So, how do I analyze it? We write mass times acceleration is equal to force, and this force we write in two parts, the actual real forces and plus pseudo forces. In our case, the real forces all add to 0 because this is at rest in the lap frame which I take as inertial frame. So, real forces must add to 0. So, this part is gone. Pseudo force, if I write this pseudo force, then it is m times omega square times r in outward direction. Centrifugal force is away from the axis. So, I can write this as r cap, where r cap is this direction, unit vector in this direction r cap. But then acceleration of this particle acts in from this frame. It is going in a circular path and therefore, the acceleration has to be towards the center, and the acceleration is v square divided by r, which will be same, which will be equal to omega square times r, but that will be in this direction. So, this m a is m into omega square into r, and that is in minus r cap direction, whereas this side total force including pseudo force is this much, which is in plus r cap direction. So, that means we are still missing some pseudo force. There are more pseudo forces. Even after taking centrifugal force, our equations are not satisfied. So, that means in a rotating frame together with centrifugal force, we need some more forces, some more pseudo forces. And how much should be that? How much should be that? If I am to get this m into omega square r minus r cap, and here it is m omega square r cap, what I should have? I should have yet another force which is minus 2 times m omega square r cap. Then this equation will be satisfied. Then the pseudo force, after taking all this pseudo force, a mass into acceleration is equal to total force. And indeed, you need such pseudo forces if you are using rotating frames. And if you work out this, I can recast it little bit. If you see, the velocity is in this direction, this is the velocity at this instant, it is going in this circle. So, you can see if I write what is omega cross v. What is omega cross v? Omega, remember, is in z direction, this is the direction, this is z direction. So, omega is in z direction, so you can write this as omega k cap, and velocity is v, which is omega times r, and that is in minus phi cap direction. I call it minus phi cap direction this way. This is plus phi cap direction and this is minus phi cap direction, and this is omega square into r. And what is the direction of this vector? This omega vector is in this direction, v vector is this direction, omega cross v will be in r cap direction. So, this is in r cap direction. So, this term here, this yet another pseudo force here, this I can write as minus 2 m omega cross v. Minus 2 m omega cross v. M is the mass of the particle, omega is the angular velocity of this rotating frame. Remember, I have to take the direction also into account, and then cross product velocity. This is velocity of the particle with respect to this rotating frame, and this term is called Coriolis force. So, in rotating frames of reference, you need centrifugal force, you also need Coriolis force. I am assuming that the frame is rotating at a constant angular velocity. If this angular velocity of the frame also changes with time, you will have yet another pseudo force. But assuming that the frame is rotating with uniform velocity, these two are definitely needed. But if the particle is at rest with respect to the rotating frame and you are using that frame, then this V is 0, then the Coriolis force is not needed. In the experiments that I did in previous lecture, there you notice that this V was 0, whether it was foam particles in tube or other experiments, the velocity of the particle with respect to the rotating frame, either it is 0 or it is parallel to this omega, so that omega cross V is 0, then Coriolis force is not needed, only centrifugal force will do. Okay, so let us do an experiment which will show the effect of Coriolis force. I have this coin in my hand. Suppose I just put it here and rotate this disc, and from this rotating disc we will analyze this coin. So, if I rotate it with some slow velocity, the coin remains at rest in the frame of the disc. It is at the same distance on the disc, it is at the same place. So, if you analyze that, the centrifugal force was there outward. So, that would like to take it away from the axis, but then friction of the surface is there, static friction, and this frictional force is equal to the centrifugal force, and hence the total force is 0, and in this frame this remains at rest. But if we increase the speed so that the centrifugal force m omega square r increases, in that case the static friction will have some limit, and after that it will slip. So, let me give it a larger angular velocity, and you can see that this fellow has gone away from the axis. We placed it somewhere here in the middle, and now you see it is at the edge. Let us repeat. I start from here, give it an angular velocity, and you see where this disc is, where this coin is. This coin is right here at the edge. So, from this middle it has gone away. This is centrifugal force, is going away from the axis. But is it going on that radial path? Once it starts going, is there a Coriolis force, because now there is a velocity with respect to this disc. So, let us to see that path, let me wet this coin in water. So, I wet this coin in water and put that wet coin here, and then give this disc a velocity, and then expectedly as the coin moves on the disc, it will leave a track of water which we can see later leisurely. So, let us do that. So, I rotate it and it has gone out. Let me stop the disc and analyze the path of this coin with respect to this disc. Look at this path, look at this trail of water here. It is not going radially away, it is deflecting in transverse direction. Is this the right direction if I take Coriolis force into account? Let us work it out. I had rotated the disc clockwise as seen by me. So, omega vector is vertically downward, and as seen from this disc, the coin starts in the radial direction because of the centrifugal force. So, velocity is in radial direction, and omega is in vertically downward direction. So, what is omega cross V? Omega cross V is in this direction towards me, and therefore minus of omega cross V will be in this direction. That is the direction of Coriolis force, minus 2m omega cross V. So, minus 2m omega cross V in this scenario, when velocity is radially outward, omega, which is the angular velocity vector of this frame, is downward, vertically downward. So, minus 2m omega cross V does have a direction in this way, and the coin is deflecting in that direction as seen by this water path. So, that is the Coriolis force. Here is one more very interesting experiment. This is a tissue paper roll, and I put it here on the rotating disc, and I will rotate the disc, and you see what happens to the roll. It has opened up. See, the roll has opened up. But I put it again and again rotate it and see what happens. It does not open up. So, what is the difference? I put it this way and then rotate and it opens up. I put it this way and then rotate and it does not open up. So, what is happening? As I am putting this on this rotating frame, if I work from this frame, because of the centrifugal force, it goes out radially little bit. But once it goes out radially, gets some speed, velocity is there with respect to this disc in the radially outward direction. Omega is there vertically downward because I am rotating it clockwise. And then again this minus 2m omega cross V Coriolis force acts, and that force is towards this direction. If radially outward velocity and angular velocity vector downward, work out what is minus omega cross V, it is in this direction. So, the force is like this and it does not open up. But if my roll is like this, once again when this disc is rotated from the disc frame, centrifugal force creates some kind of radial velocity outward, and omega is there. Once again the Coriolis force is in the same direction, but if I apply the force in this direction, it opens up. So, it opens. So, you can explain it in terms of Coriolis force. So, if I rotate it with my left hand so that it goes in anti-clockwise direction, omega will be vertically upward, and then the Coriolis force direction will also reverse. So, now the Coriolis force will be towards me. If I am looking at this end, the velocity will be this, omega will be this. So, omega cross V with a negative sign will be towards this. So, in this situation it should not open up because the Coriolis force will be in this direction. Let us see. Yes, it did not open. And reverse, do it this way, and with the left hand I will rotate it so that it will go Anticlockwise, omega will be upward, Coriolis force should be in this direction and it should open up. Just see, it does. So, that is how the Coriolis force works, and we live on the planet Earth, which is rotating about its north-south axis. So, we indeed use rotating frame of reference, and therefore, whatever moves with respect to the Earth may experience Coriolis force unless omega and v are parallel. And because of this, there will be a transverse deflection in the things, and that shows up in many ways. Our cyclones are because of that, because of pressure difference, air mass moves radially towards the center or away from the center, and then the transverse force make it a cyclonic movement, and many other things which are there. If you project something with a big speed where the range is large, then that lateral deflection can be visible. So, all those things are effects of Coriolis force.